Yep. All right, I should be recording. How many fives did I say we were gonna have?
0.
We had no fives. Now I'm gonna go ahead and tell you, guys, we might not have fives tomorrow. Like this could be a fan five where like your score might stay the same today, tomorrow, Wednesday. You might not start clicking till Thursday. Um, it is one of the more challenging fan fives that we've had. So go ahead and flip it over. And no, that's you know what? That's not true. We will have fives tomorrow. Because we had a good amount of threes and fours, which is great. The only the questions that I felt really good about were 1 and 4. Because I think 1 for sure, we've done a lot of these. 4 we've kind of done in the past. The other ones I was iffy on. So can somebody tell me what kind of question number 1 is? Oh, that is not enough hands for as many of these as we've done. I'd expect more than that. Jordan, do you know? Guys, you are interpreting a remainder here. It says 730 people in line to ride the Runaway Train roller coaster. The ride can carry 7 people at a time, equal groups of 7. What is the fewest number of times they must operate the ride? So, guys, how many people have to ride this roller coaster? So, be all of them. So that's 730 people. Yes.
Yes.
All right, Santiago, you good over there? You gonna close that? Thanks, sir. So let's start with our long division, guys. I'm not even going to put the steps on here. We've been using this almost every day, especially changing improper fractions to mixed numbers. So let's talk it out. Can 7 go into 7?
Yes.
How many times?
Once.
All right, 7 times 1?
7.
7 minus 7?
0.
What's my next step? Right?
Oh, you bring down the 3.
Bring down that 3. Who can tell me how many times 7 can go into 3? Kyle?
0, so you have to bring down the other 0.
Look, so here's where the steps maybe do come in handy. We divided, we multiplied, we subtracted, we brought down that 3. I have to divide. Now, I can't skip multiplying and subtracting and bringing down. You just told me 7 cannot go into 3. So what would I put up there, guys?
0.
I got to put a 0 up there. There's my division. So now I'm going to multiply by that 0. 7 times 0.
0.
0. If I go 3 minus 0, that is. And now I can bring down that other 0. And I have to go again. This right here is long division. So back to the top. Who can tell me how many times 7 can go into 30? It does not go in evenly, but it doesn't have to. Samuel? Y'all agree with that?
Yes.
Yep. Goes in 4 times. 7 times that 4.
28.
And then if I subtract, that leaves me with
2.
All right, so what would my quotient be? Just straight up long division, Reagan, I got what? Y'all, 104 remainder 2 is not an answer choice because that's not a thing. You can't ride a roller coaster 104 remainder 2 times. So that's why Jordan told us we got to interpret the remainder. Who can give me my 3 possible answer choices? Let's make this easier on ourselves. Skylar, what are they? That's if I ignore it.
2.
That's if I use it. That's if I push up. So what answer choices can I go ahead and get rid of? Like, I'm not even going to waste any time on them, Jordan. Not going to waste time on 14. Jace, not going to waste time on 15. And guys over here, what can I scratch out? 2. And that, look, logic. You got 730 people that need to ride this ride. You're going to run it 2 times? Like, that doesn't even make sense. So I know that I'm either going to ride this ride 104 times or 105 times. What's the word in that question that makes people not check it and just pick an answer? Skylar, y'all keep seeing the word fewest and saying 104. Well, let's check it. If I had 7 people ride this ride every time and it ran 104 times, those who checked it, who has it on their paper? Who has 104 times 7 on their paper? Good. Lindy, what was it? Wouldn't be that.
Okay.
You might have just read it wrong. Here, do it with me. 104 times 7. All right. Ones place, Lindy. Yep. All right. 7 times 0. Hold on. 7 times 0.
Here.
plus 2. Just gonna give me 2 and then 7 times 1. So look, a lot of people who missed it told me 104. What is wrong with that? Nothing wrong with the math. Math's good. But what's wrong with that? Daniel?
That's less than 200.
Y'all, that's not 730 people. Sophie just told us everybody has to ride. So 104 would not be enough. I would push up. I would run it one extra time. Do I have 735 people? No, but you have to run it that extra time. That ride just wouldn't be full. Those extra 2 people right here, they would just have the whole ride to themselves. You cannot do it if it's not enough. So when you go back to the original answer, if you run it 104 times, those 2 people are going to be left, and Melania and Cesar don't get to ride. We wouldn't do that. We push up, get the extra one, and allow them to do it. Don't let fewest throw you off. That's why in the past I've told you, act like it's not there. And check it. You'll know you're right, or you'll know you're wrong. Any questions on one?
Sure.
Raise your hand if you got one correct. So that to me should be the highest, and it's not going to be, which I don't know if that's a good thing or a bad thing. But that worries me a little bit with how low it is. No questions were positive. All right, maybe tomorrow we'll get back into that check-in and all of that. All right, number 2. I'll be honest, I can't remember if we've done this or not. I'll say this, though. This is really big in 5th grade. We do a little bit of it in 4th grade. But you'll do it a ton next year. So this week, I'm going to show you how to do it. Once we get to it when we're supposed to, I'll tell you why we do it. But can I get somebody to read number 2, please? Hey, we wait. Let's go. Pulse check. Let's go. Reagan.
There were 2. He gave 6 of the bird. And she kept the rest. How many balloons did Cara?
Once I show you this, you'll be able to tell me if we've done it or not, because I don't remember. First, guys, you got to know what a dozen is. Who can tell me what a dozen is? Josiah? It's 12. So, guys, if I have 2 dozen, how many balloons do I have? That's number 1. Kyle?
24.
All right, I know I got 24 balloons. Y'all, anytime I find a fraction of a whole number, I draw the same picture. This is what I'm looking for tomorrow. As soon as I get your notebook, I'm going to number 2, and I'm looking for this picture. If I'm finding the fraction of a whole number, I always draw a rectangle, and I'm going to put my 24 balloons inside. Just like that. Now, you could draw 24 circles. I don't need to do that. That's going to take me longer than it needs to. Here's why that fraction is really important. It says she gave 5/6 of the balloons to her guests. I'm going to take my picture and I'm going to use the denominator and I'm going to split it into that many sections. So if my denominator is 6, I'm going to split my 24 balloons into 6ths, just like this. And I always double check behind myself to make sure I counted correctly. 1, 2, 3, 4, 5. We're good. So can somebody give me an equation to match exactly what I just did? I just took 24 balloons and split them into 6ths. So that would work. That's in the fact family, but listen to it again. I took 24 balloons and split them into 6ths. Charlie? All right. 24 divided by 6. And then since Sophie gave us the fact family, Sophie, what would that be? If I'm dividing 24 by 6, that would give me, I could do 4. Perfect. Now, does this look familiar?
Yes.
So maybe we have done this before then. So think about this for a second. Does anybody know what that 4 represents? And I'm going to ask you the same question every day. You're going to get sick of hearing it. Does anybody know what that 4 represents? Grayson, do you know?
It represents the like if you divide it by 6, like it equals the the one she got left, the one
He's so close. Kyle?
the leftover amount.
Yeah, but that's not. Now look, it worked out to where that's going to end up being the answer, but that's not what it represents. I'll give you one more try. Ready? Oh, she was so close too. Guys, when I took my 24 balloons and split it into 6 sections, that means there are 4 balloons in all of these sections. That is the hard part. The easy part is just reading and labeling what it tells you. It said she gave 5/6 of them to her guests. So I would circle 5/6. These belong to the guests. You can even shade your picture if you want to. 3, 4, 5, 6. That means this right here, that's what's left. The question said, how many did she get to keep? Well, it worked out that that answer would have been 4. What worries me tomorrow is we're going to get to this step right here. You're going to divide, and you're going to think that this is always the answer. It's not. This right here is going to help you find the answer. This number right here is going to tell you, hey, there's 4 of these or 9 of these, whatever these in each section. Then you have to label. Bless you. Do you have to draw that picture to get it right? No.
No.
And you'll learn other strategies. But right now, that's what I would suggest if you were stuck. Yes, sir.
I multiplied 5 times 4.
Well, that would give you what she gave to the guests.
Then I added.
Okay. Does anybody have any questions on that? So we have seen that before?
Yes.
Okay, I thought we might have done it. Yes, sir.
So will this like the way I did this for my picture, would this work every time?
Yes.
Roger?
You drew the balloons, right?
Yeah.
It would work. It's going to take you longer. I think that might be a little bit faster. If you're more comfortable doing it that way, do it that way.
Okay.
Actually, I would say this. Would you draw that same picture if it said there's 96 balloons?
No.
Okay. So lower numbers, if you want to do that, cool. Bigger numbers, maybe just the actual number. All right. Raise your hand if you got 2 correct. It was, I don't even remember.
4.
What letter? B? Yep, B. Raise your hand if you had that one. All right. All right, y'all. Number 3 is where I would be locked in. I'd already be locked in, but if you're not paying attention as best you can and taking notes, this is the one right here. This is brand spanking new. And this is something we're going to start doing later in the week and next week. But this is something that always gives people issues. Can I get somebody to read number 3, please? Jordan, go ahead.
A red
Yep.
and that is 3 and 8 and 1/8 feet long. She also has a purple ribbon that is 1 and 5/8 feet long. How many feet longer is the red ribbon than the purple?
So when it says how many feet longer, guys, if I want to know how much longer this one is than this one, what operation should I be using? Hey guys, it's just not enough hands. It's just not enough hands. For as many people that did it correctly, there's not enough hands to be participating. Jordan? Yeah, guys, I'm going to subtract. First of all, I don't like how these mixed numbers look. You know how I write them. I just can't type them that way. So the first thing I would do is I would rewrite it. So we're going 3 and 1/8 minus 1 and 5/8. Now you'll see some people will stack these up like you would 2 numbers. I always have it horizontal. That's the way that I've always done it. I'll end up showing you the other way, but this is kind of how I start. Now we've added mixed numbers before, and we've always said, hey, start with the fractions, then you start adding the whole numbers. We're going to do the same thing here. So if I started with the fractions, what do you notice? If I had to do 1/8 minus 5/8, what do you notice? Sophie? She said you have to regroup. Guys, can I do 1/8 minus 5/8?
No.
That's just like if I said I can't do 1 minus 5. Because in subtraction, you have to sometimes borrow from the next place value, which in this case, we got to do that too. So I have to find a way to make this fraction bigger. I need 1/8 to be bigger than 5/8. And she just told us I might have to regroup. I may have to borrow. Does anybody have any ideas? Again, we've never done this before. Samuel, do you have an idea?
Take from the whole number.
Okay. Should we do that? I mean, I like that. He says let's take from the whole number. I agree. He's right. So we're going to do this. I'm going to take 1 away from 3. That changes 3 to what?
2.
Okay. Now, I'm holding that 1 in my hand. Can you see it?
Yeah. I see that.
I see.
But I have to put this 1 back as a fraction. I can't just put it back as a whole number. I got to put this back as a fraction. Now, you just said I'm holding 1 whole, right?
Right.
Who knows what fraction I'm holding? Ooh, I see some confident hands up. It's 1 whole. I'm putting it back as a fraction. If you miss it, who cares? We've never done this. Cesar, what do you think? Ooh, he says I'm holding 8/8. Where in the world did he get that from? He used this right here. Where did he get that from? Cesar, you tell me where you got it from. Don't tell me it was a lucky guess. Oh, guys, look. Your denominator is what?
8.
8. So whatever fraction I'm holding has to be 8, and it has to be equal to 1. Well, if a fraction is going to be equal to 1, what is true about the numerator and the denominator? How?
They are the same.
Have to be the same. So look, I'm going to turn that 1 whole into a fraction. It's 8/8. And I'm going to put it on top of the fraction I already have. Because the whole point of me taking was to make it bigger. So if I put that 8/8 on top of 1/8, does anybody know what my new fraction would be? 8/8 on top of 1/8. Grayson?
9/8.
It would be 9/8. Now you're probably looking at that and saying, dude, you got a mixed number with an improper fraction. We don't mess with that. We had to. That's the only way that I could subtract these mixed numbers. I had to make it bigger. Now, if my answer looked like that, that would be different. But now I can go ahead and set up my problem. I can rewrite it. So now if I started with my fractions, could I do 9/8 minus 5/8?
Yes.
Yeah, we spent all last week on that. Who can tell me what that fraction would be? 9/8 minus 5/8. Monty? So if you help her out. We know that 9 minus 5 is going to be 4. We know the denominator is not going to change. Perfect. All right, now mess with the whole numbers. What would 2 minus 1 be? Anybody? Well, that was a lot of work right there. We got 1 and 4/8. And wouldn't you know it, it is not an answer choice. That stinks. All that work we just did just to have made a mistake. Did we make a mistake?
No.
You are always going to try to do what, Jordan? Simplify. Now, with answer choices, you could cross multiply. I would like you to be in the habit of simplifying. But guys, when it has 4/8 up there, that's one I would hope we can snap our fingers and we already know. What would 1 and 4/8 be in simplest form, Skylar? Your numerator is half your denominator. We know it's going to be 1 and 1/2. Y'all, that's a beast. That is not an easy question. It's going to take time. Now, this question would be a lot easier if it was this, because you could subtract right away. But if you need to make it bigger, that whole number is where you're going to get it from. And depending on what your denominator is, that's going to tell you what fraction you're holding. It's going to take time. Yes, Hal?
Couldn't you, if you cross multiply, like use your whole number to your advantage with the answer choices?
Yeah, like you would only check A and
Yeah.
B. Yep. Don't understand what he's saying there. Like when you got 1 and 4/8, if you wanted to cross multiply, don't waste your time on C and D. Now, if you compare it to A and B and nothing's right, you made a mistake. But yes, absolutely. Raise your hand if you got 3 correct. I don't care if it was lucky. Because of those 7 people, I say probably 6 of them got lucky, and that's all right. Maybe tomorrow we won't have to. All right. Anybody got questions on that one before I keep moving? All right, number 4. This was the other one I said I felt pretty good about. Says the soup kitchen served 13 and 5/8 gallons of soup on Saturday. That's a lot of soup. They served 11 and 3/8 gallons of soup on Sunday. What is the total amount of soup served on Saturday and Sunday? Most important word in that question, and it tells me exactly what to do. I'll wait till I get more hands because we should all know this answer. Jace, what would it be? Y'all, when I see total, I know I'm going to be doing some addition here. Same exact thing. Start with your fractions, then roll with your whole numbers. Who can tell me what my fraction would be if I go 5/8 plus 3/8? Grace?
1 whole.
What would the fraction be?
Oh, 8/8.
8/8, but he's thinking ahead. Good, smart. And then if I added my whole numbers, hopefully you're stacking these on top and adding like we normally would. Reagan, what would that give you? Now, 24 and 8/8 is correct. That is perfect math, and it is not an answer choice. You will never see that as an answer choice because of what Grayson just said. And it kind of goes back to number 3. Y'all, we have to know that that is equal to what?
1.
It's equal to 1. Now, some people are going to get that answer and they're going to say, ooh, let me simplify. And it's just going to give them this, which is still not an answer choice. You have to know that that right here is equal to what?
1 whole.
If they're the same. So you're replacing that with 1 whole, and then 24 plus 1 obviously would give you
25.
which would have been C. So anytime you're getting that fraction, same number, same denominator, make sure you're changing that to 1 whole. It won't be like that old. Just happened to be this one. Questions on 4. I think this was the highest number. Raise your hand if you got 4 correct. All right. Hey, double digits.
Yay!
We needed that. All right, number 5 will be the biggest jump tomorrow. Whatever the number is today, I would not be surprised if we Ric Flaired this question tomorrow. It says, what is 5/10 plus 3/100? First thing I would do again, I'd like to have them where the numerator is directly over top of the denominator. And of course, most people who missed it, they chose A or B. What do you guys notice? It should jump out at you. I feel like I'm talking to the same 6 people. Lily, what do you notice? Y'all, those are not the same, are they? Have we ever this year added fractions when the denominators are different? No, we've made them look the same. Now, with tenths and hundredths, it's pretty easy. Look at 3/100 and you tell me, can I change that to tenths? I heard yes and no. Somebody who said yes, tell me how I change this to tenths. Kyle?
You take away the 0.
Whatever I do to the bottom, I must do to the top, right? Can I take a 0 from the denominator?
No. I mean, yes.
I absolutely could. What about my numerator?
No.
Nope. Guys, I can't change this to tenths. So I got to change my tenths to hundredths. By doing what?
Not the bottom.
I'm multiplying my numerator and my denominator by 10 to get to 100. I'm adding a 0 to both. Could I add those fractions together? I absolutely could. Who can tell me what it should have been? Jordan? 5,300, guys. You got to make them look the same. Let me review this real quick. Who can come write that as a decimal? Take target up here. That's just a, if you want to use that, sure. I don't know what that is. All right. Does he have to put the 0 in front?
Yeah.
Nope, he doesn't have to. But that would be 0 and 5,300. Guys, tomorrow on number 5, they got to be the same. Either both tenths or both hundreds. Let me stop recording before I forget.